There is a threshold in nuclear physics that is measured not in explosive yield or delivery range, but in mass, a specific quantity of material at a specific level of isotopic enrichment, above which a state possesses what the non-proliferation community calls a breakout capability. Below the threshold, the capability is theoretical. Above it, the capability is operational. The difference between those two conditions, measured in time required to convert enriched uranium stockpile into a functional weapon, is assessed in weeks, not years, not months, weeks. The facility that the Iranian government had constructed beneath the heavy water production complex at Arak was not a reactor. It was not a centrifuge hall. It was a vault, an underground storage complex designed to hold the accumulated output of the Iranian enrichment program at levels of purity that the IAEA's reporting had been tracking, with a specific language of escalating concern that international organizations use when they are describing a problem they are not permitted to solve. The vault was not publicly acknowledged. Its existence had been established through collection that the intelligence community had been building for 3 years, through a combination of environmental sampling from underground water sources in the Arak region, signals intelligence that characterized the security protocols of a facility whose surface profile did not justify the protection it was receiving, and imagery analysis that identified the construction signatures of an underground complex whose dimensions and access architecture were inconsistent with any function other than long-term secure storage of high-value material. When the stockpile estimate in the target folder crossed the threshold, when the accumulated mass at the assessed enrichment level produced a breakout timeline measured in weeks rather than months, the folder moved from the category of intelligence product to the category of targeting requirement. The decision that followed was made at the level where decisions of this category are made, in a process whose duration and participants will not be described, with the understanding that what was in the vault could not remain in the vault and that the vault itself had to be eliminated rather than merely rendered inaccessible. Rendered inaccessible left options. Eliminated left a geological record. The facility's position within the Arak complex presented a targeting problem that was distinct from any previous deep penetration mission in one respect that mattered above all others. The material stored inside the vault was radiologically significant. A weapon that breached the vault and dispersed its contents into the surrounding geology and water table did not eliminate the threat. It relocated it from a contained storage environment to an uncontained dispersal pattern that created a different category of problem, potentially less immediately threatening, but longer lasting and harder to characterize. The mission could not merely destroy the vault. It had to destroy the vault in a way that eliminated the material inside it, drove temperatures and pressures inside the storage chambers to the levels required to render the enriched material permanently unsuitable for any further processing. The weapons engineers who worked the kill mechanism had done this analysis before, in classified assessments that had never been applied to a live target. They applied it now. The assessment produced a specific employment requirement. The weapon had to achieve detonation inside the primary storage chamber, not above it, not adjacent to it, but inside it, at a depth and position that placed the explosive yield in direct contact with the stored material, rather than transmitting its effects through intervening rock. Direct contact. The precision requirement that this imposed on the fusing solution was the tightest that the GBU-57 program had ever been asked to meet. The geological profile of the Arak facility's subsurface was the second distinct challenge. The Arak region sits on a sedimentary basin whose substrate transitions from near-surface alluvial deposits through a clay interbed layer into a harder, carbonate rock formation at depth. The transition between the clay interbed and the carbonate rock was the layer at which the facility's engineers had positioned the storage vault's ceiling, a positioning decision that reflected their understanding that the clay's energy-absorbing properties made it the most effective natural shock mitigation layer available in the local geology. A weapon detonating above the clay interbed transmitted a fraction of its energy to the vault below. A weapon that penetrated through the clay and detonated inside the carbonate formation above the vault ceiling transmitted its energy through rock whose acoustic impedance matched the vault structure's own material properties. The engineers had chosen the geology as carefully as they had chosen the depth. The fusing algorithm had to find the clay-carbonate transition, recognize it from the deceleration signature, and count precisely the additional depth required to reach the vault interior. The algorithm was tested against geological samples from the target area. It was validated. It was loaded into the weapon. The mission package that carried that algorithm was built around a single B-2 Spirit, carrying two GBU-57 Massive Ordnance Penetrators, one for the primary storage vault, one for the secondary storage annex that the target folder had identified as a connected but physically separate chamber, housing the material that the vault's rotation protocol moved out of primary storage during maintenance cycles. Both chambers had to be addressed. Neither could be left intact. The employment solution placed the two aim points at a separation that required the aircraft to make two release passes on diverging headings, a sequence whose geometry the planning cell had optimized to minimize the time between releases while maintaining the GPS solution accuracy that the fusing precision requirement demanded. The defense architecture surrounding the Arak complex was not the densest that the B-2 community had trained against, but it was oriented with a specific awareness of the facility's value that translated into a layered coverage whose inner ring was designed to deny the close-in release geometry that deep penetration weapons required. Two HQ-9 batteries provided long-range coverage of the approach sectors from the west and northwest. A Bavar 373 on the high ground east of the complex covered the remaining approach geometry. Inside that outer layer, three Tor M1 batteries covered the specific release corridors that the weapons employment geometry required. Corridors whose dimensions had been mapped by the facility's defense planners with the same precision that the targeting cell had used to establish the weapons release parameters. The defense had been built to deny the shot. The mission had been built to take it anyway. The B-2 lifted off at 9:17 p.m. The routing to the Arak complex from the forward location required 12 hours and 8 minutes at the mission's required cruise parameters. The route transited the Arabian Sea, entered the Gulf of Oman on a track that kept it in international airspace through the strait, and turned north into Iranian territory on the approach corridor that the planning had optimized against the HQ-9 coverage geometry. The corridor was not a gap. It was the vector through the coverage at which the combination of the B-2's radar cross-section profile and the EW package's suppression capability produced an assessed detection probability that the planners had accepted, and that the pilot, reading the assessment in his brief, had accepted with the specific equanimity of a person whose professional relationship with risk had been calibrated over 19 years into something that looked like indifference and was not. The tanker contact at 1:43 a.m. completed in 18 minutes over the Central Arabian Sea. The pilot made the connection on the first attempt in conditions that the boom operator described as routine, and that the pilot would not have described at all, because describing a routine refueling contact would have consumed time that could be used more productively. He ate during the transfer. The tanker departed. The B-2 continued north. The EW package activated at 7:22 a.m. local time, 37 minutes before the planned penetration corridor entry, against the long-range coverage of the HQ-9 batteries west of Arak. The two EA-18G Growler flights providing the primary suppression were operating from the carrier group in the Gulf. A third asset, a land-based platform operating from a Gulf partner nation's airfield, provided supplementary suppression of the Tor M1 inner ring. The three-asset architecture had been designed with overlapping coverage responsibilities that preserved mission capability if any one asset experienced a degradation event. The degradation event that occurred was not on any asset. It was in the space between them. At 7:44 a.m., the Bavar 373 battery east of the complex activated its acquisition radar in a full-power search mode that the pre-mission intelligence had not predicted. The battery's standard operating cycle ran a reduced power emission pattern between 0600 and 0900 local as part of an emissions control protocol that the signal's intelligence picture had characterized as consistent and reliable. The full power activation at 7:44 a.m. was outside the characterized pattern. It was also on a frequency band that the Growler architecture had allocated reduced suppression power to because the characterization had not suggested full power activation was likely during this window. The Bavar 373 at full power on a partially suppressed frequency produced coverage that extended further into the approach corridor than the pre-mission modeling had assumed. The B-2's passive warning receiver detected the Bavar 373 emission at 7:46 a.m. and classified it as an acquisition radar in active search mode operating at a power level inconsistent with the pre-mission database characterization. The mission commander ran the geometry. The current track placed the aircraft inside the Bavar 373's extended coverage for the next 6 minutes and 14 seconds. The weapons release window was 11 minutes away. The Growler architecture had insufficient reserve power to fully suppress the Bavar 373 at its current output, without degrading coverage on the HQ-9 batteries in the outer ring. Degrading the outer ring created a detection risk at the approach geometry that was qualitatively different from the inner ring exposure. He had two problems. He could address one of them fully or both of them partially. Partial on the outer ring meant possible detection at range. Partial on the inner ring meant a reduced suppression margin during the release phase. He chose partial on both and transmitted the reallocation code that distributed the available Growler power between the two priorities at a ratio the planning had not pre-computed and that he was computing now in the time it took to exhale twice from the numbers the passive receiver was showing him. The reallocation produced 61% suppression on the Bavar 373 and 78% on the HQ-9 outer layer. 61% suppression on a full-power Bavar 373 left 39% of the system's acquisition capability functional. Over the 6 minutes and 14 seconds of corridor exposure, that 39% generated 11 acquisition sweeps that the fire control processor assessed against its detection threshold. 10 of the 11 sweeps produced returns below the threshold. The 11th sweep, at 7:49 a.m. and 33 seconds, produced a return at threshold minus 4%, 4% below the automated engagement authorization threshold, and a detection confidence band that the battery's engagement controller was required by protocol to log and monitor but not required to act on. The controller logged it. He elevated his personal alert level. He did not issue an order. The protocol he was following was correct. The threshold existed for a reason, and the return had not crossed it. He monitored. At 7:52 a.m., the B-2 moved past the Bavar 373's extended coverage boundary, and the returns dropped below the noise floor. The engagement controller had monitored 11 sweeps, logged one near-threshold return, and taken no action. He filed his log entry and continued his sector scan. He would review the log at the end of his shift and note that the near-threshold return had occurred in a window of anomalous frequency interference, and that in his assessment, it was most likely a jamming artifact rather than a valid contact. His assessment was professionally reasonable and operationally incorrect, and he had no way of knowing the difference. The protocol had protected the mission by setting the threshold where it was set, and the threshold had been set where it was set because of exactly this kind of scenario. The return that looks like something and might be nothing in a jammed environment, evaluated by an operator without the information he would need to make a certain determination. The protocol held. The mission continued. At 8:03 a.m., the Tor M1 battery on the northern approach vector, one of the three inner ring systems covering the release corridors, activated its fire control radar in a mode that the B-2's passive receiver characterized as a directed search rather than a routine acquisition sweep. The characterization was based on the emission's scan pattern, a focused sector search rather than a full rotation sweep, directed at a bearing that the mission commander recognized as the bearing from the battery's position to the aircraft's current track. Directed? The battery was not searching generally. It was searching specifically on a bearing that pointed at the aircraft. Something had cued it. Not the Bavar 373, the near-threshold return had not crossed the reporting threshold and had not been forwarded to the inner ring. Something else. The mission commander did not have time to determine what. He had a fire control radar in directed search mode at a range that placed the aircraft inside its acquisition envelope, and he had 7 minutes to the first initial point. He transmitted the emergency suppression code to the land-based EW asset. The asset redirected its full output from the distributed Tor M1 suppression protocol to the single battery conducting the directed search. The redirection restored full suppression on the directing battery's fire control frequency and removed suppression from the other two Tor M1 batteries in the inner ring. Full suppression on 1, 0 on 2. For the duration of the emergency redirect, assessed at between 3 and 5 minutes before the land-based asset could restore distributed coverage, the two unsuppressed batteries were operating on clear frequencies with full situational awareness in a sector that the B-2 was transiting. The two unsuppressed batteries ran 4 acquisition sweeps each in the 3 minutes and 41 seconds before the land-based asset restored distributed coverage. All 8 sweeps produced returns below the detection threshold. The B-2's radar cross-section profile at the current geometry and altitude against the Tor M1's acquisition radar without jamming degradation fell in a range that the system's threshold was designed to classify as weather clutter rather than aircraft. The system worked as designed. The threat it had been designed against in the era when it was designed was not what was in front of it. The returns were logged as clutter. The B-2 continued to the initial point. At 8:09 a.m., the first initial point. The bay doors opened. The targeting system confirmed the GPS solution against the primary storage vault's subsurface aim point. The coordinate at a depth inside the carbonate rock formation above the vault's ceiling at the position the fusing algorithm had been computed to reach after counting through the clay interbed's deceleration signature. The first GBU-57 released. The aircraft pitched, corrected, and turned onto the heading for the second pass. Bay doors closed. The weapon's descent through the near-surface alluvial deposits produced the deceleration profile the algorithm expected. The clay interbed transition arrived at the depth the geological survey had predicted, 31 meters below surface, marking the shift from alluvial to clay that the algorithm was looking for. The algorithm registered the transition and began counting the additional depth into the clay layer. At 47 meters, the clay-carbonate transition produced the second deceleration change the algorithm had been programmed to recognize. The algorithm registered it and began the final count. The prescribed depth into the carbonate formation above the vault ceiling that the kill mechanism analysis had established as the required detonation point. The fuse threshold was met at 59 meters total depth. The detonation occurred inside the carbonate formation at the position the weapons engineers had computed as direct contact geometry with the vault interior. The overpressure that entered the vault through the fractured carbonate ceiling was not what the vault's structural engineers had designed against. They had designed against overpressure arriving from above, a weapon detonating in the alluvial surface layer, or at most penetrating into the clay interbed before detonating. A weapon that reached the carbonate formation and detonated at direct contact geometry with the vault ceiling had not been in their design calculation. The vault ceiling failed. The material inside the vault experienced temperatures and pressures that the weapons engineers had computed would exceed the threshold required for permanent material degradation by a factor that left no recovery pathway. The enriched uranium that had been accumulating in the vault for 3 years ceased to represent a breakout capability at 8:10 a.m. and 14 seconds. The aircraft was already on its second attack heading. The second pass initial point arrived at 8:13 a.m. and 41 seconds. The bay doors opened. The second GBU-57 released toward the secondary annex aim point on a fusing solution computed against the same geological profile, but adjusted for the annex's position within the carbonate formation, a position that the target folder had established as slightly shallower than the primary vault, reflecting a construction decision that had optimized the annex for access rather than maximum depth. The algorithm's adjustment was 9 meters. The second weapon reached its fuse threshold at 50 meters and detonated. The secondary annex and its contents experienced the same outcome as the primary vault, 14 meters shallower in the same geological sequence. At 8:14 a.m., the Arak complex security network registered simultaneous seismic alarms from sensors positioned above both aim points. The security duty officer attempted to contact the underground vault management station. No response on primary communications. No response on backup. The complex's surface emergency protocol, the sequence of steps that the security architecture required when contact with the underground facility was lost, began executing at 8:16 a.m. The protocol took 37 minutes to produce a surface inspection team at the primary access tunnel entrance. The inspection team reported at 8:53 a.m. that the primary access tunnel was passable to the 40-meter depth mark and impassable below it. The vault was below the 40-meter mark. The duty officer transmitted his report at 8:57 a.m., 47 minutes after the first weapon had impacted. His report described the situation with the precision that training produces and that does not require speculation. Contact lost, access blocked, nature of obstruction unknown, requesting engineering support. The engineering support that arrived would take 11 hours to establish what the seismic signature had already told the monitoring stations and what the B-2's mission confirmation code had already told the planners. Both chambers were eliminated. The material was gone. Not relocated, not dispersed, not recoverable. The breakout timeline that had been measured in weeks had been replaced by a timeline that did not exist because the material it required no longer existed. The vault that had been built to protect the accumulated output of Iran's enrichment program had protected it until the weapon that had been built specifically to reach it arrived. The B-2 reached the post-strike tanker rendezvous at 11:44 a.m. The transfer completed in 16 minutes. The aircraft turned west. The data link carried its confirmation code. The planners who received it cross-referenced the seismic data. Both events confirmed. Both aim points. The 11 sweep near-threshold detection event at 7:49 a.m. was noted in the debrief as the closest the mission had come to exposure, and was assessed as having been correctly managed by an Iranian engagement controller who had followed his protocol without knowing what he was deciding. The protocol had been on the wrong side of the outcome it was designed to produce. It had been right by its own standard and wrong by the one that mattered. That was the standard the planners had built the mission against. The numbers that closed the package: 12 hours and 8 minutes of flight time. 2 GBU-57 Massive Ordnance Penetrators employed on 2 attack passes with a 4-minute, 27-second interval. 1 Bavar 373 full-power activation outside its characterized emission cycle that forced a mid-mission Growler power reallocation, leaving both suppression priorities at partial coverage. 11 acquisition sweeps by the partially suppressed Bavar 373. 1 at threshold -4%. Logged and monitored, not acted on. 1 Tor M1 directed search activation from an unidentified queue, managed by emergency suppression, redirect at the cost of full coverage on 2 adjacent batteries for 3 minutes and 41 seconds. 8 sweeps by the 2 unsuppressed batteries, all below threshold. 0 aircraft lost. Both vaults eliminated. The breakout capability that had been accumulating for 3 years was gone. The threshold that defines a nuclear breakout is a number, a specific mass at a specific enrichment level that converts theoretical capability into operational reality. Numbers can be reduced. They can be eliminated. The reduction is not diplomatic. It is physical. It is irreversible. And it is measured not in the enrichment level of what remains, but in the geological silence of what does not. The vault is empty. The mountain is unchanged. The weeks no longer exist.